So yeah, again, welcome to week 8, Introduction to Machine Learning. My name is Rohan. I'm a TA for this course, and this will be the last week. And uh, today we will discuss about clustering algorithms. Right. So let's begin. So what is clustering? Right. So let's say you have any data. Uh, Data which can be represented in 2D like this, right? So x-axis could be any value and y-axis could be any parameter. Like x and y are basically parameters. So if you see the example in the right side, for example, this is the annual income, this is the property value, right? So these are, data points of various people, different people. So this person has this much annual income and this much property value, and based on those features, if we are clustering groups of data, uh, you can see that you can form clusters, three clusters in this according to this original data. So these clusters are basically nothing but data points which are very similar to one another, and you make a group out of them, right? So you can make three groups in this case, right? So you can also make two groups. Like this could be one group, this could be another group. Now, how many groups to make and what is the optimal number of group? Those we'll discuss in detail in the upcoming slides. But you see one important difference between classification and clustering. So you see this is the data of, let's say, height and weight of people. Some people are given, right? So these are the green ones, which are the height and weight of people, adults. So you would expect a greater height and a greater weight in case of adults, whereas in case of children, you will observe a lower height and a lower weight. So with that, you can like draw a line and form a you know logistic regression model with this, right? So we have seen how we can make logistic regression model. So why do we need clustering? Uh, I mean, we could do a good enough job with uh, regression, like classification or logistic regression. So the question is, why do we need clustering? The main thing is that clustering is a unsupervised learning algorithm, right? Main difference is that clustering is an unsupervised learning algorithm, whereas classification is a supervised learning algorithm. So by supervised learning, I mean that these tags, like the target variable, are already given in case of clustering, right? So they know, I mean, you would know in advance that these are adult data points, these are children data points, and then you put a line to separate those data points. But in clustering, you would just get data. Nobody would tell you that, okay, these are adults or these are children and so on, right? Nobody would tell you that. So based on some data points, you would just get height and weight of some people, and then you can like make clusters and see that, okay, these are some clusters which has higher height and higher weight, whereas these are some clusters with lower height and lower weight, and then you make an inference, make a uh, judgment that, okay, this could be probably the data points of adult people, this could be of children, and so on. And using those inferences, then you could you know use those insights into some problem that you are solving, right? So for example, on this side, as I was saying, like this is the annual income, this is the property value. So based on these three clusters that you have made out of all these people, so let's say if you are selling some product, right? So let's say you want to sell a house to someone, right? So what will be the target segment of your population, right? which people you should target, right? So if you see that, okay, these are people, the green points are the people with lower income, right? So you won't go into target those people, right? If you are selling a, costly house, let's say. So the people you would target is that, the people who have higher income but still don't have much property, so they would be, willing to buy more and more property, and they will be your target segment, right? Similarly, this could be for, if you are selling any other products in the market, and uh, they could be your uh, target population, right? So another example could be, in fraud detection. For example, on the x-axis you have amount of transaction, on the y-axis you have number of transactions. So you make clusters out of these two parameters, and you find that, okay, some variables are there which has higher amount of transactions, but the number of transactions are very low. So let's say this is one person has made a transaction of, let's say, a huge amount, let's say 50 lakhs, but only one time transaction. So he has never made another transaction which is, you know uh, even remotely closer to that value, right? So in that case, you can identify, okay, this might be a fraud transaction, and in that way, uh, the bank can reject the transaction and take necessary actions. Okay, so yeah, right. So someone is asking if we can like resources for practicing projects. So I had done, a lot of hands-on using Python. So maybe in the previous weeks also I have done, and you know this week also I will do so. And all those notebooks I have uploaded in. Uh, I have given the link in the YouTube comments, and maybe you can go through those notebooks and make modifications to those and make your uh, practice those, basically. Yeah, so that is a good place to start. Okay, so yeah, now moving on to the next part. What are the types of clustering, right? So these are the different types of clustering: partitioning, hierarchical, model-based, density-based, graph-theoretic. So we will mainly cover the first three in this lecture, right? And density-based and graph-theoretic will not cover in detail. Okay, so partitioning is basically the simplest way you can cluster things, right? So, for example, if you have this data, you can visually see that, okay, this can be partitioned into three different clusters, right? So in partitioning, you see that you don't have any uh, you know outliers, or you know this any point has to be in one cluster on or another, right? It's not possible that some point is not in does not belong to any cluster. So basically you partition your whole space into two or three or any number of parts, such that uh, whichever the data point falls in that part, that belongs to that particular cluster, and in other parts as well, right? So that is a partitioning algorithm. Hierarchical is when you have, basically what you do is that, so in this example, if you see that, animals is a, bigger uh, term, or, it includes all the animals. And within that, you can form, groups of vertebrates, invertebrates, birds, mammals, and, so on, right? So this is a hierarchical, as the name suggests, that you go from a, you know a general category to a more and more specific one, right? So from animals, which is more general, you go to uh, individual categories like birds, mammals, and you can even go deeper. So another is the model based. So we will discuss this we will use a Gaussian model. So in this case, what will happen is that what you do is that based on the data points that you are given, you try to fit some model to your data, right? So if you take, let's say, a Gaussian model, so what will happen is that you will fit a Gaussian curve to your data point. And I think we have discussed what a Gaussian curve when we were discussing, I guess, in SVM, when we were discussing kernels and all, so on, right? So Gaussian curves look something like a kind of a hill kind of shape, right? So in which the points which are towards the tail of the Gaussian has lesser probability to be in that particular cluster. So here you can have, like, let's say you can have three Gaussian functions: one for the red, one for the green, and one for the blue. And the green Gaussian fits the green points, and the outside points have lesser probability to be in this cluster, right? So in this cluster, it could happen that some points are not uh, belonging to any particular cluster, right? Unlike in the case of this partitioning algorithm, right? And another could be db scan. So db scan is basically an example of density based algorithm, right? So it's basically checks the wherever the density of points are more, it will basically club them together and form a cluster. So, for example, if you see the blue points are very closer to each other, right? And the density of points between the blue points are more, whereas in the yellow case also there are a lot of yellow points which are closer to each other, which forms a circle, right? So if you apply a partitioning algorithm in this case, then it will function very poorly, because it will try to form something of a this kind of line, as I'm showing here, split it into two parts, which is not right, because in a clustering algorithm, what it checks is the distance between the 2 points, right? So, for example, the distance between this side of the blue points and the distance to the distance of this side of the blue point is a large distance, right? But still, they are found in the same cluster, right? So that's the beauty of this density based clustering, and how it you know avoids some limitations of the partitioning based one. Right. But again, in this case also, like the Gaussian case, we can have outliers, the density based algorithm, right? Whereas, as I said, in the partitioning based algorithm, you have to be in either one cluster or the other. You cannot have outliers. And the last part is the graph theoretic algorithm. So it involves a lot of mathematical details, which we'll not go into. But graphs are basically, we have these data points in this space, and when you have a you know uh, connection between all these data points, you can form different clusters within these graphs. So there are a lot of mathematical details using Laplacian, and which requires a lot of linear algebra. But we'll not go into detail of this. At the end, I will give you some references for this graph theoretical algorithm for anyone who is interested to know more. Okay. So yeah, any questions? So Pratima is saying question 3 and 5 of week 8. You mean week 8 assignment? Yeah. So 3 involves the question 3 is about calculating using k-means algorithm to, okay, and 5 is uh, yeah, 5 is again um, it's about hierarchy. I'll cover those topics, and then uh, since you can ask that. So I'll do it in detail, do some examples in detail. I'll do some calculations and maybe then it will be clear. Okay. So yeah. So basically, what are uh, these distance measures? So let me talk about k-means clustering first. Okay. So okay, before going into k-means, let me talk in general about distance measures. Okay. So, why do we require this distance measures? Because, so let's say if you're talking about this partitioning algorithm, right? So, we want to take points which are closer to each other. We want to take them together. We want to make one cluster uh, together, right? So similarly, we make different partitions, and we need to know which are the points that are closer to each other. So for that, we need to have some measure of distance between 2 points, right? So how do we calculate the distance, right? So that is the question. So for example, I think we have done this earlier as well when I guess we are doing uh, other algorithms. And if you remember, like we used to take an LP norm, right? Even when we were doing kernel functions and those things. So we are introduced to this function called LP norm. So if you are trying to calculate the distance between 2 points, xi and yi, so what you do is that you take xi minus yi whole to the power p, and then take a pth root of that, sum over all the you know uh, all the dimensions, and take the pth root of that. And if the value of p is 2, that is just the L2 norm, that is just the Euclidean distance, right? Similarly, L1 norm would be if p value is 1, right? And similarly, L infinity norm is just basically maximum of all the x1 minus y1, x2 minus y2, and so on, right? So, okay, so let me do one example like how to calculate the distance, right? So, okay. Okay, so let's say that you have 2 points. Uh, yeah. So let's say you have. So basically, let's consider first two dimensions only, x1 and x2. But in general, your data can have any number of dimensions, right? So based on the features. So here we are considering only two features. So again, let's consider, like, for example, the height, weight, and the adult children classification that we're talking. So for example, this is one data point of a children, let's say, which have a height of, you know let's say 5, and weight of, let's say, 25. Whereas here is data point of an adult, which has a height of 6, and a weight of around 50. Okay, right? So what is the distance between these two data points? So how do you calculate the distance? So as I said, we were discussing LP norm, right? So LP norm, in this case, let us use L2 norm, right? So, but this could be any not necessarily you have to take p value equals to 2, right? So what we'll do, the formula is square root of uh, basically 6 minus 5 whole square plus 50 minus 25 whole square, right? So that's what the formula was, right? So the formula, if you remember, it was uh, xi minus yi whole square summation, and here is root. summation over all the uh, dimensions, right? So in this case, it will be 6 minus 5 whole square plus 50 minus 25 whole square. So this is just nothing but the Euclidean distance between these 2 points. If you just draw a line between these 2 points, a straight line between these 2 points, that is the length of that line, right? So you can calculate this distance. This will be like root over of 626, right? So this is how you calculate the distance for L2 norm. Similarly, for L3 norm, you just take cube root, and inside instead of squares, you will have cubes, right? And similarly for uh, other LP norms, you can calculate the distance. Okay. Okay, so for any questions regarding the exam, we'll discuss it at the end. Right now, just focus on the whatever is the content is there. Okay, so whatever I'm teaching. So if you have any questions on this part which I'm teaching, so let's discuss that first. So any questions till now? Okay. So similarly, this is one measure of distance using LP norm, and another could be cosine distance, right? So if you have two vectors, A and B, the distance between those 2 points would be 1 minus the cosine similarity. Cosine similarity is taken as A dot B divided by mod A mod B, right? So again, I will do it. I'll calculate it for one example. So let me go back here. So this is the L2 norm distance that we have calculated over here. Now we will do cosine distance. So for the same points, we'll see the cosine distance, right? So if you see, let's consider this to be the A vector. Let's consider this to be the B vector. So what will be the so if you remember, cosine similarity is defined as A dot B divided by mod A times mod B, right? So A dot B is basically 5 into 6 plus 25 into 50, right? Okay, so Monica is asking what I said about cube root. So in the L2 norm, if we are doing, let's say, L3 norm, right? So what will be the distance in case of L3 norm? So I'll just show it over here. Let's see. So L3 norm, it's not visible, right? Yeah. So L3 norm, the distance in norm would be cube root, and then inside you will have 6 minus 5 whole cube plus 50 minus 25 whole cube. That's what I'm saying. Is that clear? L4, L5, L6 for any distance, right? Okay. Coming back to the cosine distance. So, yeah. So I was calculating the cosine similarity. So cosine similarity is A dot B by mod A mod B. So A dot B is 5 times 6 plus 25 times 50, right? So how to calculate A dot B? So if you are familiar with vectors, if you know that if A and B are two vectors, then the dot product between the two vectors basically the product of the x-axis value, that is 5 times 6, plus the product of the y-axis value 25 times 50. If you are given higher dimensional data, if you have z-axis, then you have to add the product of the z-axis value as well. Okay, so this is the a dot b divided by mod a mod b. So what is the mod of a vector? So mod is just the root over of the x axis square plus y axis square. This is the mod a, right? So if you see a is 5 comma 25, right? So root over of 5 square plus 25 square. That is the magnitude of a. Similarly, mod b would be 6 square plus 50 square, right? So yeah, you use a calculator, calculate this thing, and then you'll get the similarity. Okay, and then the cosine distance would be 1 minus similarity between a and b, right? You calculate this, subtract this value from 1, you'll get the distance between these 2 points. Okay, any questions? Yes. Yes, this is the cosine similarity. So if you see the formula, uh-huh, right, right, right. So yeah, that's it. Okay. So I think we were talking about similarity when we are discussing recommended systems, right? So if you remember, um, I mean, if you even don't remember, please go back to the that lecture and just look at recommended systems. And in recommended systems, where we need to calculate the similarity between two users or two items, right? We used to calculate similarity. And if you remember that we were using the Pearson correlation coefficient to calculate the similarity between two users or two items, right? So this formula for Pearson correlation. So xi minus x bar times yi minus y bar. So if you want to calculate the similarity between two different uh, users, for example, in case of recommended systems, uh, x would be one user, y would be another user, and using this formula, you can calculate the similarity between two users. Similarly, you can calculate the similarity between two clusters in this case, right? And similarly, this is another measure is given by which is called the Mhalonobis distance, which is actually x minus y whole transpose, the inverse of the uh, covariance matrix. S is the covariance matrix times x bar minus y bar, right? So I will not do a calculation of this, Pearson correlation again, but I did a detailed calculation on how to calculate the Pearson correlation in the recommended system lecture, right? So please go back to this lecture, and there I did a detailed, uh, of similarity there. Okay. So yeah, but these are some of the questions that could be asked in your exam to calculate the distance between 2 points, and Pearson to calculate the correlation, Pearson correlation coefficient, and so on, right? So you should be able to do these calculations in your um, you know yeah, basically you should practice these calculations once before the exam. Okay, now to check the quality of clustering, right? So yeah, so I think we have discussed this confusion matrix many times during our course, right? So uh, I will explain it again. So basically, when you are classifying some problem, so you basically you have some mismatch between your actual value and the predicted value. So if the actual value is one, you predict. Yes. Yeah, yeah. The PPT would be shared in the Google Drive, and whose link will be shared. Whose link will be available in the YouTube, you know, comments or description. So I've shared it in the previous weeks as well. So yeah, in that drive you can find it. So PPT, notebooks, notes, everything will be available. Don't worry about that. Okay, so yeah, as I was saying that to calculate the quality of clustering, we look at this confusion matrix, and if the actual value is one, and your model is also predicting it as one, then it is called true positive. Actual 0 predicted 0, true negative. Actual 0 predicted 1, these are false positives. Actual 1 predicted 0, these are false negatives, right? So basically, if you see that the false positives and false negatives are basically your error, you are like making a mistake in classifying those examples, right? Your model is making a mistake, right? So accuracy would basically be TP plus TN divided by total, right? So because these are the correctly classified samples upon the total number of samples. But apart from accuracy, you can also calculate precision and recall. So I have earlier defined like why precision and recall are important in some purposes, right? So for example, accuracy is not enough always, right? So precision could be important in some of your problem statement in which you want to maximize the true positive. You don't care about the true negative. And similarly, recall, yeah, and so on, right? Sorry, yeah. So in both cases, you are trying to maximize true positives, but precision has false positives in the denominator, whereas recall has false negatives in the denominator, right? So in recall, you want if you want a higher recall, basically you are trying to minimize your false negatives, whereas in precision, you try to minimize your false positives, right? So yeah, so these are precision recall, and this we have already discussed. Now, what are the measures to identify how good your clustering algorithm is performing? So these are some of the measures. So first one is the RAND index, which is this RAND index is basically just the accuracy. If you remember, true positive plus true negative divided by the total thing. This is called the RAND index. So this is similar to accuracy. So obviously you can understand like if accuracy is higher, then you know your model is performing better. Second could be F measure. So again, we have discussed this in one of our previous classes. F measure is basically, 2 times precision recall divided by precision plus recall. So this is trying to take a balanced approach between both precision and recall, right? So higher F measure means better clustering. Another could be, so these are some of the new terms that we would see, that Jaccard index, and next is the Dice index. So what are these Jaccard index and Dice index? So again, if you see the formula, this is just the Jaccard index is true positive divided by false positive plus true positive plus false negatives. Dice index is twice times true positive divided by false positive plus true positive plus true positive plus false negatives. Now, one physical interpretation of how to visualize this Jaccard index. So basically, if you see from this Venn diagram, so if you see that these are basically false positives and this white region are basically false negatives. So in between the intersection is basically your true positive, right? And everything else is basically true negative, right? So if you see that these this shaded, this darkly shaded circle that you see over here, these are all the data points which are predicted as positive, right? So these are all the data points which your model predicts as positive, this circle. And then the white circle is all the data points which your model predicts as negative, right? So now at the intersection, you have this true positive. So basically, Jaccard index could be also represented as this A intersection B or A union B, right? So if you have any two sets So let me give you an example. So let's say set A. So we are doing Jaccard index, right? So if you have a set A which contains, let's say, maybe 1, 3, 7, 9, right? Set B contains 3, 9, 10, 12, right? So what is your A intersection B? A intersection B will have two elements. Which are these two elements? 3 and 9. A union B, it will have how many elements? It will have 1, 3, 7, 9, 10, 12. Right? So 1, 2, 3, 4, 5, 6. 6 elements. So your Jaccard index would be 2 by 6, 1 by 3. Right? So that way also you can calculate Jaccard index. Also, if you have been given a classification problem and you have to just calculate what are the true positives, true negatives, false positives, false negatives, and then using this formula you can calculate the Jaccard index as well. Right? And you can get some questions on this to calculate this index as well. Right? So the last part is the another measure which is called the Davies Bouldin index, right? So which is the DB index. So how to calculate this DB index? So if you see, so if you have, let's say, you have made some clusters out of your data points. Let's say you have made 3 clusters, right? And within each cluster you will have some data points. Now this Sk is the intercluster distance. So which means that the summation, so if you just consider one cluster, right? Uh, let's say the first cluster out of the 3, and you calculate the distance of each points from the centroid of the cluster, right? And you sum them up and divide it by the number of points in that cluster. That is the intercluster distance, right? And the intercluster distance is basically the distance between any two clusters, right? Now you define RKL, which is SK plus SL divided by the MKL, right? And then you define RK as the max of RKL, and your DB will basically be 1 by K summation of RK. So I just explain, demonstrate what I have just said in a graphical way. So yeah, let me you know, let me do it here. Okay. So what I was trying to say is that, so let's say you have these data points, right? So these belong to one cluster. The red points belong to another cluster. The blue points belong to another cluster. So you have these points, these 3 clusters, right? Now, how to calculate the centroid of a cluster? So I will show one example how to calculate the centroid of, let's say, the red cluster, right? So this is the cluster that you have, the red one, and how to calculate the centroid is basically you obtain the coordinates of each of the points. So let's say this point has coordinate as 5 comma 2. This point has 6 comma 3. This point has 5 comma 4, right? So these are the coordinates of the 3 points in the cluster. So the centroid would be basically you just sum up the x coordinates, 5 plus 6 plus 5 divided by the number of points, that is 3, right? Comma sum of the y coordinates, 4 plus 3 plus 2 divided by the total number of points again. So that is the, so this will become 16 by 3, comma 9 by 3, which is 3, right? So this is the centroid. This is the coordinate of the centroid of this cluster. Okay, so you just sum up the x coordinates, sum of the divided by 3, comma the sum of the y coordinates divided by 3. And if you have more dimensions, if you have a three-dimensional data, if you have z coordinate as well, then the z coordinate of the centroid is again obtained by summing up the z axis divided by the total number of points. Okay. So similarly, you can calculate the centroid of each of the clusters, right? So let's say, according to this code, this value, so this will be like 5.3, comma 3. So value would be somewhere, over here. So this would be the centroid. Okay. So if you look at this point, this is the centroid. Similarly, I can take the centroid of other clusters. So let's consider this C1, C2, and this will be over here, which is C3. Okay, so these are the centroids of these three clusters. Okay, now what is the inter uh, intercluster distance? Right. So intercluster distance is basically, so there are two terminologies you should be familiar with. One is intracluster, okay, another is intercluster. So intracluster, so let me talk about intercluster first. Intercluster is the distance between two clusters, let's say C1 and C2. Okay, so if you want to calculate the distance between this cluster and this cluster, you just take the distance between the centroids of the two clusters. And we already know how to calculate distance. We just showed how to calculate using LP norm and cosine distance and all those things. So this C1 will have some coordinate value, C2 will have some coordinate value. You take the distance between C1 and C2. That is the intercluster distance. That is the distance between two clusters. Okay. Similarly, intracluster distance is basically distance within a cluster. So let's say if you want to take the distance within this cluster, what you do is you take the distance of each of these individual points from the centroid. So for example, let's say these are 1, 2, 3. These are 3 points. Okay. So you take the distance of each of those points, 1 with C1 plus 2 from C2 plus distance of 3 from C2 divided by 3. Right? So you can calculate the distance of 1 from C1, C2, 2 from C2, 3 from C2, and then divide by 3. That is the intracluster distance. Okay. Now coming back to the slide. So yeah, this is the intracluster distance as I was saying. Then this is the intercluster distance. Okay. And then you can calculate both. And from there, you can calculate this RKL, which is the SK plus SL. So considering that K and L are two clusters, so in this case, let's say you want to calculate between cluster 1 and 2. So you can calculate the intracluster distance between 1, intercluster distance between cluster 2, divided by the intercluster distance between cluster 1 and cluster 2, right? And then you find between all such pairs of clusters. So you do it between C1, C2, C2, C3, and C1, C3, right? And then RK is basically the max of max of all the three, right? And this DB index is basically the summation of all those RKLs that you have calculated, right? So these are some of the measures of to determine how good your clustering is. So again, just to recapitulate it, we discussed precision recall, we discussed RAND index, F measure, Jaccard index, Dice index, and DB index. So these are some of the measures. So any questions on these? Let's move on to the first algorithm. So we'll discuss three algorithms. One is k-means, which is a partitioning algorithm. One is model-based algorithm, which is Gaussian mixture model. And third will be hierarchical model, right? So we have developed all the things that we need. So for example, how to calculate distance, what will be the quality of clustering. Now we will see how these clustering are actually being performed, right? So for example, so let's say you have been given this initial data, right? You have given some data points. Now you want to cluster them. So for example, what you do, so you start with some initial seeding. And by initial seeding, what I mean is that, so you choose randomly any 2 points as your initial centroid, right? So in this case, I have chosen, this point as one centroid, this point as the second centroid. In this case, I want to cluster it into two clusters. But in general, you can do it for 3 clusters, 4 clusters, any number of clusters. If you have 3 clusters, you need to choose 3 centroids. Okay, but we want to do it for do divide the data into 2 clusters, so we choose 2 centroids as any 2 random points. Okay, so that's how we start. Now, in the next iteration, what we do is that we calculate the distance of all these points from this centroid. Let's consider this C1, and let's consider this C2. So we calculate the distance of all points from C1 and all points from C2. Now we see whichever points are closer to C1 than C2. For example, let's say, let's take this point. This point is basically closer to this C1 than C2, right? So we in the next iteration we assign this point to the red cluster, right? And similarly we do it for all the points. So whichever points is closer to C1. Okay, so one step I missed in between. So after we assign the cluster centroids in the first iteration, what we do is that, yeah, we calculate the points which are closer to this than this cluster. So these 3 points, if you see, these 3 red points are basically closer to this cluster than the this point. Okay, obviously, if you see that, these points are obviously be closer to this thing, you can visually see that, right? So this point will be farther from this red cluster. So whichever points are closer to this cluster, we assign it to as red. So 3 points which are being assigned as red. So now in the next iteration, what we do, we update our cluster value, right? So what we do is that we get these 4 points and we take the centroid to be the centroid of these 4 points. And we have already discussed how to calculate the centroid. It is just summation over the x-axis and the y-axis divided by the number of points. So we update the centroid position over here. Similarly, we do it for the blue point. Now, if you see, the blue point has moved towards the right side because there is a higher density of points on the right side. So the centroid will move towards the right, and this point has moved a little bit towards this side because we have a higher density, on this side. And then we update the cluster position, and then again we check which are the points which are closer to this cluster than this cluster. We assign them as red, and whichever the points are closer to. So for example, even after you iterate after this point, there will be no reassignment of points. For example, no point from the blue cluster will go into the red cluster, and so on, right? So there is no shifting between clusters, or even the centroid, even if the centroid of the cluster do not, change after some iteration. That's when you stop. Okay, all right, right. So as I was saying, you iterate number of times and till you uh, converge where there is no change in the centroid or the change in the uh, points of uh, the cluster, right? Now there is some term called WCSS, which helps us to determine what is the optimal number of clusters in this that can fit this data, right? So you don't know, like, initially, without, if you have a big data, you don't know, like, whether you want to cluster the data into two clusters, three clusters, or you don't know how many clusters. So how to determine what is the optimal number of clusters that can uh, you know cluster your data? So there is some term called WCSS, which is called the uh, weighted cluster sum of squares, right? So what is that distance? What is that weighted cluster sum of squares? It is calculated by calculating the distance of each point from the cluster whole square, right? From the center of the cluster, distance of each point from the center of the cluster whole square, and then you sum it over all the points in the cluster, and then sum across all the clusters, right? So basically, if this is the scenario, so you will have this point minus this point minus this point whole square, again this point minus this point whole square, this point minus this point whole square, and so on. Do it for all the points in this cluster, and then again sum it over, do it for the all the points in this cluster, and then sum them. So what does this measure? This measures that how closely packed your cluster is. How, you know. So if you have a lower value of weighted cluster sum of squares, that means that your clusters are more closely packed and more tightly bound. So basically that's good for us. So lower the WCSS, lower is the better is the clustering. So if you have like highly dispersed points, so if you have, let's say, one point very far away from the centroid, so that means it's a bad clustering, right? So you have, but if you have closer points towards the centroid, you will have lower weighted cluster sum of squares (WCSS), and you will have a better model. So if you see, the WCSS will always decrease as you increase the number of clusters, right? So because as you increase the number of clusters, the the tightness with which the clusters are formed, that increases, right? So clusters are the points are very close to the centroids of the clusters, right? So that way, WCSS will always decrease with increase of number of clusters. But you have to choose some optimal value of the number of clusters, such that you know uh, at which you form this elbow point. So if you see, this is a graph which shows that how WCSS on the y-axis of WCSS, and it decreases as you increase the number of clusters, and the point at which it has a sharp increase, a sharp decrease, that point is called the elbow point, and that is the optimal number of clusters that you can choose. So in this particular case, you need to choose 5 clusters. So in general, what you do is you run your algorithm for multiple number of clusters. You try it for cluster two clusters, 3 clusters, 4 clusters, and so on. And you plot this graph and you find which is the optimal number of clusters, and finally you model your data using that value, right? So again, what are the advantages and disadvantages of k-means clustering? So k-means clustering is simple, understandable, and items are automatically assigned to clusters. Yeah, but disadvantages are you have to pick the number of clusters before, and all items are forced into a cluster. As I was saying earlier, it's a partitioning algorithm, so either you fall in one cluster or another, and it is too sensitive to outliers. So if you have some outlier in some part, you see that it will be affecting the clustering and so on. So is there any question on k-means clustering? Yes. Mm-hmm. Mm-hmm. Right. Sorry, can you repeat? Lat long, you have some lat long data. Hmm. What variation? Uh, 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 Sorry. So you have some lat long data. So lat long data will tell you the data will have like tell you basically different geographical locations. Is that right? So at different geographical locations, you have different temperature or weather conditions. Okay. Yeah. So how are you planning to uh, you are trying, what is your problem statement? So you have to define your problem statement first. Are you trying to see which are the places which has higher temperature and so on like that? Yeah. So I think you can apply it. You can uh, apply that, but there could be some, differences. For example, like when you have lat long data, it will depend on like how you calculate the distance between 2 points, right? So if you see that in a globe, the distance is not the Euclidean distance; it's a curved manifold, right? So you can visualize that, right? When you are drawing a straight line on a globe, it's basically not the Euclidean straight line. So since you have a lat long data, you don't while you calculate the distance between 2 points, you have to be careful about that. That you take that into account. You have to do it in spherical coordinates and uh, so on, right? Right. Hmm. Hmm. Okay. So, I mean, before applying k-means, you can visualize your data. So basically, in Python, you can plot 3D graphs, right? So you can plot contour graphs or color plots if you just Google it. So first, you have to see that you know on the two axes, you have to plot latitude and longitude, and you can depict the color as the temperature. So redder temperatures can, redder colors can indicate higher temperatures, or and bluer colors can indicate lower temperatures. So in that way, you can like you have to first plot and see like which areas, which latitudes are giving redder colors. That means those latitudes have higher temperature, and uh, which latitudes and longitudes are giving bluer color. That means those are having lower temperature. So that way you can visualize. Sorry. Yeah, you can. Yeah, I mean, you can do it in using k-means. So you have some data, and you can apply k-means algorithm in that. But it depends on what you are trying to extract out of it. Because this problem statement, if that is your problem statement, you just want to know which latitude and longitude have higher temperatures. It doesn't require k-means. It's just an overkill, I would say. But if you have more, uh, you know, uh, other, insights that you want to draw, then maybe uh, you might need something. Okay. Okay. So yeah, actually, in related to your question, we will see one hands-on exercise in clustering. So let us do some quickly do a hands-on exercise. So this is the data that I have, right? So uh, so let's say you have some customer, you have multiple customers. These are their data, gender, age, annual income, and spending score. So spending score higher means that that person has propensity of higher spending. So you can apply this to any market research or anything like that. So for example, yeah, oh yeah, yeah. Sorry. Yeah, I think I've zoomed it now. I think it's visible now. Okay. So yeah. So as I was saying that you have yeah, the spending score is showing how what is the propensity of spending of a particular customer. Higher spending score indicates that that customer is willing to spend more uh, on some item or anything. So this could be used as a market research kind of an thing. So you want to target, let's say you want to target those customers. You are launching a new product and you want to target those customers which have a higher spending score. So how will you determine which are your customers, right? So these are the pre-processing steps. We had described those earlier. I will not go through in detail on those, but I'll share the notebook for you to see. And yeah, so this is the 2D clustering based on age and spending score. So for example, we want to see, this is the scatter plot of age and spending score. So on this axis you have age, this axis you have spending score, right? So this is, let's say, the person with age 60 has a lower spending score, but in general, if you see, on this side, people with younger age has a higher spending score, right? So we want to build a cluster out of these, and now we want to determine how many clusters we want to make. So for example, we are running a loop and making 15 clusters, right? So 1 to 15. So we are making 15 different, we are running it for 15 iterations and making so in the first iteration we are doing one cluster, two cluster, and so on, right? And we are doing, these are some of the parameters that you should see, okay? And we are fitting and making this elbow plot that we talked about earlier, right? So if you see here, the elbow is forming at somewhere at 4, right? At 4. So 4 is the optimal number of clusters, right? So then what we do is we apply k-means for k equals to 4. And again, we build our k-means algorithm and fit the algorithm, and you know these are the centroids that we are calculating from here, right? And then again, we are plotting our data. So these are the 4 clusters that they have made, right? So again, if you see that, okay, these are the customers which have, lower spending score, right? And these are the customers which have higher age but medium spending score, lower age, medium spending score, and lower age, high spending score. So these are kind of the insights that you can get from these k-means clustering. So if you want to have a item launched, so these will be your target customers, right? So these have higher. spending score, and so on, right? And yeah, so these could be some of the applications. Then again, you can do it for k equals to 5 and so on, right? So this will make 5 clusters, right? So yeah, you can experiment with this. I will share the notebook. Okay, and then again, these are based clustering based on annual income and spending score, right? So you see, earlier we did it on age and spending score, and now we will do it on annual income and spending score. So here you see the, the elbow happens at k equals to 5, right? And we did it. We built a model. We made 5 clusters. So these are the some of the clusters. So for example, if you have a higher annual income, you have a, these are the people with higher annual income, higher spending scores. These are the people with lower annual income but high spending scores, right? So depending on your problem statement or market uh, idea, you can cater to a particular cluster of customers, right? And then again, we do it for 3D using age, annual income, and spending score. So three variables. We again do the elbow plot. This time the elbow happens at 6, so we make 6 clusters, right? And these are the clusters that you can see over here. Let me just wait a minute. Okay, right. So any questions? Yeah, so this is how a 3D plot would look like, right? So if you see, you have 6 different clusters with indicating 6 different colors, right? So you can like rotate this image. You can see that on one axis you have annual income, another axis you have spending score, and another axis you have age. So you can see like this purple ones. These are the clusters of people with higher annual income, and what is this? Let me see the x-axis. The x-axis is probably age. So higher annual income, and uh, I guess lower spending score, and you know lower age, or yeah, I guess. So you have to see this using this. This is a movable 3D graph, right? It's hard to visualize, but you can rotate this and see that. Okay, so these lies in the lower age, you know, and higher spending score, and higher annual income. So these are the points. Similarly, these blue points are lower spending score, lower age, and you know and higher annual income, right? So and so on, right? Now another interesting example, I just not go into the details. So if you, let's say, if you have these images, right? So these are the image of a tiger, fox, lion, and so on, wolf, panda, right? So what you can do is that, so these are the input space of the colors of these images. So these images, if you see, are very colorful, and this contains millions of colors, right? So these are the possible colors in the RGB scale, right? So so many colors are possible for these images, right? So now what we want to do, we want to cluster these colors into, let's say, 5 clusters, right? So for example, what if you see, this is the original number of colors that are used in these images. So there are so many different colors that are being used in these images. Now we make 5 clusters out of these different colors. So if you see, there are 5 distinct colors, and each of these colors are basically the centroid or the mean uh, of a particular cluster. So this is 1, 2, 3, 4, 5. So out of these 5 images, we are trying to make the image of this dog. So this is the original image if you see, and this is the image of the same dog with just 5 images, 5 colors, right? And we are clustering those colors based on the similarity between uh, different colors and so on. So this is a 3 color image of this fox, and similarly you can see 2 color image of this lion. So this just make an image out of these just 2 colors. So for example, as the example you were talking about, to how to segregate temperature into of different latitude and longitude. So basically, we just plot the data and just apply this clustering. Maybe make 2 clusters, so that will give you a cluster of points which has higher temperature, and a cluster of points which has lower temperature, and so on, right? And so again, so these are different type of images. This is the original image, and this is a 16 color image. So these are 16 different colors, and 10 color image of this fox, right? And so on. So you can play with it, and you can. So these look like some filters of colors, and these are like very interesting to see. Okay, so let me go back to my slide again, and okay, so now we'll do model-based clustering. So we saw the algorithm of k-means clustering, uh, and now, so what is the model that we are using over here? So right now, as I said, as I was talking earlier, we want to fit a Gaussian model to all our data, right? So this could be some Gaussian curves. So as I said, the Gaussian curves are like bell-shaped curves which are being fit to our data, right? And we could have multiple Gaussian curves which can fit our data. So, and number of Gaussian curves that we need to fit our data, those are the number of clusters. So in this case, this data, let's say, is being fitted with 3 Gaussian curves, and so we can make 3 clusters out of these, right? And as I said earlier, that unlike k-means clustering algorithm, which are partition-based clustering algorithms, in this kind of algorithms you can have outliers, and we'll see how. So let's say you have been given this data, right? You have given this 1D data, out of which these yellow points are belong to yellow class, blue points belong to blue class. Then what you do is you can fit a Gaussian curve to this blue and yellow points. So yellow points would be fitted to this yellow Gaussian, blue points would be fitted to this blue Gaussian. And how you calculate the mean and the variance of this Gaussian is just you take the mean of this yellow points and you take the variance of this yellow point. Similarly, you do it for the blue points, and that's how you get the mean and the variance of this blue and the yellow Gaussian. But here is one problem. In clustering, you don't know the tagging of the data. These are unsupervised learning algorithms. So you don't know which belong to yellow class, which belong to blue class, right? So that is the problem. So earlier, if you remember, we used to do it for, we used to do the SVM kernels and so on, right? But here, that is the problem, that you don't know the tagging of the data. Okay, so Shoaib is asking that, is it possible to implement k-means clustering on images and cluster it with respect to the features in the image, like analyzing eyes, eyebrows, etc.? So if you can do that, if all those features have different color properties. See, clustering is being done on basis of some properties which the model can see, right? So if your eyes have some particular color, if your other features have different color, then the clustering algorithm can differentiate them and make different colors out of them, right? So then the clustering algorithm can determine those features, right? But in general, for uh, you know to get the features out of an image, people generally use neural networks. So those are very powerful algorithms that we have discussed, and those are generally used to extract features out of images, right? But in general, as I said, that if you have um, something which distinguishes between different features, so let's say the color of your eyes is different from the color of your hair, or let's say, right? So then the clustering algorithm can make different color of your eye and different color of your hair or other features, right? As we saw, right, that same color points are being clubbed together and make into a uniform color, like as we saw in the example. But different color points or pixels are being averaged over into a different color, like that. Okay, so coming back, as I was saying, that you don't have labelings in this case. So what you do is you take a Bayesian approach to this problem. So initially you have this data. So what is the likelihood that you choose this? You choose to be a Gaussian function. So you could choose other models as well, but here we are choosing Gaussian function, right? So this is how you calculate the posterior probability, right? So this is just Bayes theorem, nothing else, right? So this likelihood you define as Gaussian, and then posterior probability. This is just the Bayes theorem. So B given x1 is x1 given B times PB divided by P of xi. If you see, and this is the law of total probability in the denominator, right? So this is just the definition part. I will explain how you get these Gaussians, how you optimize them in the next slide, right? So in the next slide, there is something called EM algorithm, expectation maximization algorithm. So now I'll explain how this algorithm works and how you determine the final, how the final Gaussian looks like. So initially, you start with uh, any two Gaussian. So let's say you have these points, and you start with a yellow Gaussian, and you start take a blue Gaussian. So let's say you want to cluster your data into two clusters. So you'd start with two Gaussian. So now you see what are they doing. So basically, if you see this yellow Gaussian, if you look at this point belongs to this yellow Gaussian with very high probability, right? Compared to this point. So this point is very far from this yellow Gaussian, whereas this point is closer to this blue Gaussian. So what is the probability that this point belongs to this blue Gaussian? That will be very high. Whereas the probability that this point belongs to blue Gaussian is very low. This point uh, will mostly belong to yellow Gaussian, right? So what you do is that you calculate the posterior probability, which is P of B given xi. So what does this mean? As I was saying that, B is the, let's say, the blue Gaussian. What is the probability that this xi point belongs to the blue Gaussian? So this is the physical meaning of Bi and P of B given xi, right? Similarly, you calculate AI, which is the probability that this xi point belongs to this yellow Gaussian. Okay, so you see that unlike in k-means, where you used to get that, okay, this point belongs to this cluster and nothing else, here you will get a probability. So if you see, this point is shaded as yellow, more yellow and less blue, whereas this point is more blue. So the probability of B given xi, that this point belongs to blue given this point, will be a value between 0 and 1, let's say zero point 0.3. So there is 30% probability that this point belongs to blue Gaussian, and 70% probability that this point belongs to yellow Gaussian. So that's what the value of Bi will be, right? So Bi will be, for this point, it will be 0.3. Ai for this point will be 0.7, right? Similarly, you calculate this for all the points, right? Again, as I said, the physical meaning is that what is the probability that this point belongs to this Gaussian. Now you update the cluster. So if you see how to update, the mean of the blue Gaussian next time would be this weighted average b1 x1 plus b2 x2 and so on divided by the b1 plus b2 plus bn. So what it will do is that if you see, you will have more blue points. The the b1 value, the bi value for these points which are on the right side will be higher, and therefore the blue Gaussian will be shifted towards the right. Right, the mean of the blue Gaussian would be shifted towards the right because there are more number of points which have higher bi's on this right side. Right. So similarly, if you see in the next iteration, what happens? The points have shifted. The blue Gaussian is shifted towards the right. Right. Similarly, you update the variance as well. So this is just the variance is basically the width of the Gaussian signal, right? And you repeat it multiple times until you converge. And at the end, your blue Gaussian would look something like this, and your yellow Gaussian would look something like this, right? So if you see here that all the points have some probabilities associated with it, right? They do not belong to this cluster or this cluster. They have probability of belonging to this cluster or this cluster, right? And there could be some points which are, let's say, very far away from this clusters. So they will have very low probability of belonging to, this blue cluster, right? So they could be treated as outliers. Okay. So the main point is that this Gaussian mixture model, these algorithms uh, can have outliers, can allow outliers, unlike in partitioning algorithms. So is it clear? Is there any question on this? So this is just a 1D example. You could have 2D and 3D and so on. So if you look at this diagram, this shows a 2D Gaussian model, and and so on. Right. So let me do a quick. Let me show you a quick hands-on. So you have this data of credit card uh, data that you have, right? So just to make a visualization, I have just reduced this data into 2 dimensions. And how did I do it? By using PCA, which we have discussed in previous lectures. So using principal component analysis, we can reduce the dimension of the data. Here I've reduced it to 2 dimensions so as to make it easier to visualize. So I made 3 clusters using Gaussian mixture model. So if you see, these are the 3 clusters that are being made over here, right? Now, there is something called a silhouette coefficient, which basically measures how closely packed these clusters are, right? So again, this is similar to something like WCSS, which we're using in k-means. So this is, if you read through this, you will see that the A is the mean distance between a sample and all other points in the same class. So this is like a intra-cluster distance. B is the inter-cluster distance. So higher the silhouette coefficient, better the model is. So these are the silhouette scores. So if you see after this, the silhouette score decreases, right? So this is the optimal number of clusters that you choose. So 3 is the optimal number of clusters, right? So these are the silhouette. This is just a definition. Go through this formula once, and you will see which. This is how you choose the optimal number of clusters. So another way is Bayesian information criterion. Again, you go through it. I will not explain in detail, but here I mentioned a brief explanation about what BIC is, and basically it just means that lower BIC basically indicates a better model. So this is another measure of how good your model is, right? So BIC always decreases, but you have to choose some optimal value. So for example, by optimizing the silhouette score also, so your silhouette score will become low if you go for higher number of clusters. So you have to keep that in mind as well. But yeah, there is something called something like how to see gradient of BIC scores and all those details that you can look out afterwards. But yeah, I will move on to the next part, which is agglomerative clustering. Before that, let me know if you have any questions. Okay, so hierarchical clustering. So what does it mean? So as I was saying in the previous slide with an example that you go from a more general uh, segment to a less general segment. You can also do the other way around. You can go from a less general segment and then go higher up, right? So these are basically the processes like agglomerative clustering and the divisive clustering. So what you do is, in this case, you go into from a specific segment. So you consider each of the points as your clusters, and then you cluster the nearby points together, right? And finally go into higher and higher, uh, make lesser and lesser number of clusters, and yeah, you do it, and finally you get the whole single cluster over here. And divisive clustering is just the opposite. You say that all your data points are within one cluster. So let's say all these are animals that you say, and then again you cluster the mammoth, vertebrates, invertebrates, and then within the vertebrates you cluster other parts, and finally, uh, you know, go into each segment in detail and go into the each points, right? So here the number of clusters in the divisive clustering, your number of clusters basically increases. In the agglomerative clustering, your number of clusters basically decreases as you go higher up, right? So yeah, now we'll do agglomerative clustering, and we'll see one example. We'll explain with the help of this example. So I'll do it in my notepad, but let me just explain what this data is. So So let's say you have this data of this 5 persons, right? And this is the date. This is the data like how many hours this person spends in social media, and how many hours this person spends in gym. So Alan spends 2 hours in social media and 3 hours in gym, and so on. Other people. Now I have represented this data in a very simple, graph, 2D graph. So this is the x-axis is social media, y-axis is gym. So if you see Lisa spends 5 hours in social media and 2 hours in gym, right? So that's what it means, right? 5 and 2. So it's just a representation of this data into graph. Now we want to understand how we cluster this data, right? So let me go back to my notepad now. Okay, let me go to a new one, right? Okay. So hmm, let me first, plot the data. So let's say that this is Lisa, this is Joe, this is Carol, this is Max, this is Alan, right? Okay. Now, uh, this is the data you have got. The first step, as I said, okay, this x-axis is social media, y-axis is gym. First step, as I said, you consider each of these data points as separate clusters, right? That is initial iteration. In the next iteration, what you do, you basically calculate the two nearest points in your data. Okay, let me first, also mark the coordinates of this, which will be used later on. So Lisa is basically 5 2, Joe 5 3, Caro 4 5, Max is 1 4, Alan is 2 3. Okay. So I've just marked this data. So this just means that Lisa spends 5 hours in social media, 2 hours in gym. Joe spends 5 hours in social media, 3 hours in gym, and so on. Right? Okay. So this will help us in calculating the distance. So the first step that we do is we find which two clusters are closest. So for that, what we do, we calculate the distance between all the points, right? So you see the distance between Joe and Lisa would be basically 5 minus 5 whole square. Let me write it down. Distance between Joe and Lisa, 5 minus 5 whole square plus, okay, here we are calculating Euclidean distance only, L2 norm. Okay, 3 minus 2 whole square. So this comes out to be 1. Similarly, distance between Max and Alan, you can calculate. It's 1 minus 2 whole square plus 4 minus 3 whole square. That's root 2. Right? So I will not calculate all the distances because visually you can see that this distance is higher, this distance is higher, this distance is also higher. You can calculate it and make it a distance matrix. But from this, we can see that visualize that, okay, Joe and Lisa have the lowest distance between them out of any two pairs. You calculate the distance between all the two pairs and you find which has the lowest distance. Okay, so basically let me just show you one thing. So basically you have Alan, Lisa, Joe, Max, Caro, right? Alan, Lisa, Joe, Max, Caro. So you just make a matrix like this, right? And in this, uh, so this is basically 0. Distance of Alan from Alan is 0. Distance this the diagonal entries will be 0. Here you will have distance between Alan and Lisa. You calculate it, write it over here, right? And similarly so on. So here we see distance between Joe and Lisa is 1, right? So this entry will be 1, okay? That we have calculated over here. Similar distance between Max and Alan, if you see, it will be root 2, okay, here, okay? So this represents distance between Max and Alan. Okay. Similarly, fill out this distance matrix, distance between every two pair. Now you find out which is the minimum distance. In this case, it will be Joe and Lisa, which is distance 1. So in the next step, you make them as one cluster. Okay. So this is the first cluster that you get, right? So what you do is in the next step you repeat this, and how you repeat this, so you make the distance matrix again. Okay, second. Okay, so now you have got this cluster. So what will be your next iteration? Okay. All right. So next iteration, to calculate the distance, there could be four ways. So you see now, in the first step, you used to calculate the distance between 2 points, which was pretty simple, right? Now it's a little bit more complicated because here you have one cluster, which is a combination of 2 points. So how to calculate the distance from this cluster to any point, or this cluster to other clusters, right? So that is a where there are four methods. So as I was showing in the slide, first method is single link, second method is complete link, third method is average link, fourth method is centroid, right? So I'll explain the four methods, but we will use the calculations using single link only. Okay. So what do I mean by single link? So by single link, you mean that whatever is the closest distance between these two clusters. I mean the cluster points. For example, this cluster has 2 points, right? Now, when you calculate the distance between this cluster and this cluster, which has only 1 point, ln, so what you do is you take the shortest distance between this point and the points between this cluster. So, for example, you calculate Alan and Joe, and you calculate Alan and Lisa. So, whichever distance is shorter, you take that one. That is your single link distance, right? Whereas in the complete link, it's just the opposite. Whichever distance is longer, you take that one. Okay. In the average link, what you do is you take the average of all the distances. Whereas in the centroid link, what you do is you take the centroid of this cluster, calculate the distance between the centroid. So that is the centroid vertex. So did you understand what are the different methods of calculating distance between two clusters? Okay, so we'll go ahead and we'll use the single link method. Okay, so what we do is we again make this matrix, distance matrix. So Alan, Lisa, Joe. So now Lisa, Joe has become one cluster, Max and Caro. Similarly, you have Alan, Lisa, Joe, Max, and Caro. Okay. So similarly, this the diagonal entries would be 0, right? Now, what is the distance between Lisa, Joe, and Alan? So how do we calculate? Again, as I was saying, for single link, what we'll do, we'll see what is the distance between Alan and Joe, right? So Alan and Joe, distance between Alan and Joe is basically 2 minus 5 whole square plus 3 minus 3 whole square root. So this will be 3. Distance between Alan and Lisa, that will be 2 minus 5 whole square plus 3 minus 2 whole square. So this is root 10, which is higher than 3, right? So the minimum distance is between Alan and Joe. So for the single link distance, we'll take this distance, right? Not the Alan Lisa distance. Okay. So here we will write the distance is 3. Okay. Now distance between other pairs like Max and Alan. So Max and Alan, if you calculate, it's 1 minus 2 whole square plus 4 minus 3 whole square. So it's just root 2, which is 1.4. Okay. Similarly, between Caro and Alan, you can calculate. It will come out to be 2.83. Between Lisa Joe and Max, again you have to see like whether this distance is lowest or this distance is lowest. But from visual inspection, I can like measure that Max and Joe distance is lowest. So Max and Joe distance would be, let's see, distance between Max and Joe is 1 minus 5 whole square plus 4 minus 3 whole square root. So this is 5 minus 1, that's 4 square plus 1, 16 root 17, right? So distance between Max and Lisa Jo would be root 17, which is 4.12. Similarly, this will be 2.24, this will be 3.16. Now you calculate this distance matrix and you see which is the lowest distance between any 2 points. So if you see 1.4 is the lowest one. So Alan and Max will form the next new cluster. Okay. So in the second iteration, this is your new cluster, Alan and Max. Okay. And then you repeat the process. Okay. And then you will find more and more clusters of points which are being clustered together. And finally, until you get all the points as one cluster. Right. So if you see over here on the right side is a dendrogram picture. So this is a pictorial representation of how this hierarchical clustering works. So as we saw, first we clustered Lisa and Joe together, then we clustered Max and Alan together. So if you see, Lisa and Joe are clustered together first over here, right? And then Alan and Max are clustered together. Now, how to read this dendrogram, how to know that which pair are clustered first and which pair are clustered later. So this is from this height of this dendrogram. So if you see, Lisa and Joe cluster have a lower height, whereas Alan and Max cluster have a higher height. So that means Lisa and Joe were clustered earlier, and then in the second iteration Alan and Max were clustered. Then in the third iteration, if you see, Alan, Max, and Caro were clustered, right? And after that, Alan, Max, Caro, Nora were clustered, right? uh, yeah, I don't know, in this diagram there is no Nora, but yeah, whatever. So this is how you read the dendrogram, and then finally all of the people are clustered together, and that is the thing. Now if you want to have, let's say, you want to have 4 clusters. So what you do is you draw a horizontal line along this line. You make a cut in this dendrogram, right? So if you make a cut in this dendrogram, what will happen? You will get this. You will see how many vertical lines at this horizontal line is cutting. So this is cutting 1, 2, 3, 4. So this is cutting out 4 lines. So thereby we will make 4 clusters. And what will be this 4 clusters? This 4 cluster. First cluster would be Lisa Joe. Second cluster would be Alan Max. Third cluster Caro. Fourth cluster Nora. If you want 3 clusters, you cut from here. So basically you will cutting through 3 vertical lines. So in this case, first cluster Lisa Joe, second cluster Alan Max Caro, third cluster is Nora. Okay, so this is how you make clusters using agglomerative clustering. So we'll quickly see one exercise. Okay, so again, this is just the first example that we are seeing with K-means clustering. You have people, different customers with gender, age, annual income, spending score, and this is just a heat map, right? So basically, heat map just shows, for example, if you see here, this black lines means that they have lower value, so lower value of age. The redder lines means they have higher value of age, and again for different variables. So this is the age variable, this is the annual income variable, this is spending score variable. So black means lower spending score, or red or orange means higher spending score. So why I'm showing this heat map is that because you want to cluster the similar colors together. Okay, so you want the black lines to be clustered together and the red lines to be clustered together in a separate cluster, right? Yeah. So, so this is the dendrogram diagram that I was showing. So these are for 200 customers. So if you want, let's say, 4 clusters, you make a cut like this through this. So this will be your customers cluster that you will get over there, and so on, right? So this is a visualization using a 3D graph. Okay. So here, I guess I have made. Yeah, how many clusters have I made over here? Let me see. Yeah, I guess from the colors you can see one, two, three, four, five. So I made 5 clusters. Okay. Okay, so you can play with it and see how many uh, other clusters. Yeah, so this is just a 2D plot of the spending score versus annual income, right? So same thing we have done for k-means. You can just have a comparison about uh, you know between the two algorithms, right? And so this is the analysis that you can have, right? So the green cluster is basically low income, low spending. Yellow cluster is low income, high spending, as I was saying earlier, right? So similarly, you can do it for age and spending score. So you'll have clusters like low age, younger age and higher spending, younger age and lower spending, and so on. And based on those clusters, you can, based on your problem statement or market idea, you can target specific customers for your specific product or service, like that. Okay. So, like every week, we will end this last week with some questions. So, try to study in detail about the graph clustering algorithm, which we have not covered over here. Also, study about the density clustering algorithm, DB scan. So that is also a good algorithm. You should know about that. And, for further supplementary reading, as I was saying, some of the prerequisites for this course, and not only for clustering, but the prerequisite for this course is linear algebra, and you have to. I mean, it's not necessary to know, but it will give you a good mathematical background to know linear algebra. And this Gilbert-Strang lectures by MIT OCW is a good place to start. It starts from the very basic. So these are some of the supplementary reading if you want to go in depth about machine learning in general uh, in the future, right? And yeah, also you should know about the advantages and disadvantages of the clustering methods. So, for example, I discussed some of the advantages and disadvantages of k-means clustering, which is being taken care by Gaussian mixture models, and also as I skipped some of the parts which you should go in detail, like BIC and AIC measures, and yeah, we saw an example of agglomerative clustering, but where we went from smaller clusters to higher clusters. Try to also implement and see how divisive clustering works. So you go from bigger clusters to smaller clusters, and so on. Okay, with that, let me know if you have any questions. As you can see, Monica has asked which values we have to take for the second iteration. Okay. So I guess you're asking about hierarchical clustering, the agglomerative one. Which values we have to take for second iteration? What do you mean by that? So for the first iteration, initial iteration we just made one each point as one cluster, right? Initially, first iteration. In the second iteration, we just calculate the distance between all the 2 points, and we see which point has the lowest uh, you know lowest distance. Which 2 points has the lowest distance? So we make this distance matrix. We measure the distance between all the 2 points, Alan and Lisa, Alan and Joe, Alan and Max, Alan and Caro, and everybody. We see which is the lowest distance. So you can fill out these blanks, but you can see that the lowest distance is between Lisa and Joe, right? So you make Lisa and Joe into one cluster. That's the second iteration, right? And then in the next iteration, you again check the distance between all the clusters and see. And here you have to see between single, whether it's a single linkage distance or a complete linkage weightage or so on. Here I've used single linkage and I calculate the distance between all the two clusters and we see which is the minimum distance. This time Max and Alan as the minimum distance, make it into a cluster. And then we repeat it and so on. So yeah, exactly. Does that answer your question, or do you want to ask something else? Yeah, so you can use any linkage. Uh, for exam purpose, it will be given. If you are to calculate distance using a particular linkage, it will be given in the exam, whether you have to use single linkage or complete linkage or anything. Uh, but again, which linkage to, in practical purposes, which linkage to use, that depends on your problem, and uh, you can treat it as a hyperparameter as well. And you can see which linkage is basically giving you uh, least error in your cross validation data set, and then you can see which one to use. Okay, so yeah, for final exam, I can only say, practice numericals and uh, do some calculations on your own. Uh, I mean, I have done a lot of calculations uh, starting from week one to uh, till today. So these distance calculations, and for example, in decision trees, I've done calculations on entropy and information gain. Go through those calculations. Do it on your own. And for example, probability questions that I discussed in last week, and Bayes theorem, and all those numericals. I think you have to practice and try to understand how it works, and those will be helpful. Okay, so someone is asking how the questions for model-based clustering in the exam. Yeah, so for model-based clustering, you could be asked like to calculate this posterior probability, right? So if you see over here, you could be asked to calculate this posterior probability, right? Or the updated mean for the cluster. Okay. So initially, you could be given some likelihood. So P of xi comma b would be given. You would be given some likelihood, and based on that, you could be asked to calculate uh, the posterior probability, or the from the posterior probability you could be asked to calculate the updated mean of the cluster in the next iteration. So once you know P of xi comma b, pb you can calculate like this. Okay, b1 summation of b1's bi's divided by n, and from there you can calculate the posterior probability, and using the posterior probability you can calculate the updated mean. You'll get all the values of bi's, and then you do b1 x1 and so on, and then you get the updated mean like that. Okay. Okay, any other questions from any other weeks or any assignments or anything? I think someone was asking questions on this assignment. Is it clear now, like how to do the calculations for week 8 assignment and those things? Is it clear now? Yeah, questions. Someone was asking about question 3 and 8 in this assignment. So yeah, question 3 and 8 is asked to calculate cluster centroids, right? That is very basic. We have already covered it, how to calculate centroids. And question, which was the other one? 3 and 5. So question 5 I can see is you have been given some points, and yeah, so question 5 is basically hierarchical clustering, right? That we just did right now. So you're given points, x and y coordinates of different points, and you have to again calculate the distance matrix. We just saw in detail how to calculate the distance matrix and cluster the points. So yeah, those are good exercises actually. I think you should do on your own. Yeah, Ramesh is asking. Yeah, before that, let me just conclude that question 5. Yeah, that is exactly same as what I just did at the end, right? On uh, this problem, social media and gym problem. So they are given again this x and y axis. I just showed you how to calculate distances and make clusters. So yeah, you should practice it on your own. That will be helpful for you in the final exam as well. This is just identical to this example. I think you can do it. And how to calculate Jaccard index? Yeah, as I said, Jaccard index is basically using this formula you can calculate. And there is another formula for Jaccard index which I calculated using. So if you have two sets A and B, Jaccard index is just A intersection B divided by A union B. So I think this is the example that you should be looking at. So if you have two sets A and B, you just calculate what is the number of examples in A intersection B. You have 3 and 9. Two examples, A union B has 6 points. So Jaccard index will be 2 by 6, 1 by 3. So that's how you do it. Okay. Anything else? I think so. Is there any, if there are any questions from previous weeks or any particular assignment of previous week or any particular question or anything? Yes. Week 4, problem number 4. Okay. We did one problem on week 4. Was it problem number 4? Yeah, we did that, right? Oh, yeah, yeah. Yeah, I didn't. If I find anything, probably I will post it. Um, I'll make another video in my YouTube channel, and I'll post it if I find it. I didn't go through it again, but I will see. But any other problem from week 4 do you want to discuss? Any other problem you guys are stuck in? Information. Okay. Shoaib is asking. Yeah, just a minute. Shoaib is asking information gain calculation. So I did it in the Saturday session as well, and so you can go through the extra session one. So I did it in the Saturday session, and also in week 2 I did it. Information gain calculation. So there are two places. Uh, yeah. So you see that, and I think it will be okay. And then you practice by yourself. You try to calculate, make dummy tree, and try to calculate what is the information gained by yourself. I think that will be better. So if you miss the Saturday session, you go back and see the extra session, and also you can see the week 2 session as well. And I think I also uploaded a video on calculating entropy and information gain separately, small video, which will be like probably 10 minutes video, and yeah, that won't take much time. You don't have to go through the whole 2 hours video. um, yeah, yeah. And Kavita was asking, yeah. Sixth. Okay, drug test has 1% false positives. Let me bring the question now. Yeah, this question, right? Drug test. Hmm. Yeah, you don't need the confusion matrix. So this is similar to one example that was done by the professor in the class, right? So if you see that, so in all these probability questions, one thing. Let me go back to my notepad. So one thing you have to keep in mind, you have to define the events clearly, right? What do I mean by that? Let me just Okay, let me first read the question again. So, drug test has 1% false positives. That is 1% uh, of those not taking the drugs show positive in the test, and 5% false negatives. That is 5% of those taking drugs test negative. Suppose that 2% of those tested are taking drugs. Determine the probability somebody who tests positive is actually taking drugs. Okay. Okay. So, uh, okay. So let's define first two events. So one is event T, that that means that the person is test positive. That is the first event. Second event is uh, taking the drug basically. Okay. So D means taking drug. Okay. So now what you have to calculate, you have to see what you have to calculate first. Okay. So based on these events, you want to calculate the probability that someone who tests positive is actually taking drugs. So, wait a minute. So probability that he is actually taking drug given that he is testing to be positive. That's what you have to calculate, right? Probability of taking drug given that he tests positive. Now you apply Bayes theorem. Probability of test positive given taking drug times probability of D divided by probability of T, right? Because you are given, right, that this person, so determine the probability that somebody who tests positive. So it is given that he has test positive, right? Now you have to determine the probability he is actually taking drugs, given that he tests positive. Okay, so on the right side of the slash, you have to take into account which is given. So given that he tests positive, what is the probability that he is taking drugs? That's what I have calculated. So that's what I've written in this probability form. Given that he tests positive, what is the probability that he is taking the drug? Can you do it now? Okay, so these are all problems on Bayes theorem, and again, so there is one caveat in that. So in the bottom denominator again, as I was explaining in the this is P of t. In the denominator, as I was explaining in the expression, that you have to apply law of total probability, which I explained in the probability class. So you have to be careful about that. So now, what is given in the these? What are these? So 1% false positives. So that means 1% of those not taking drugs show positive in the tests. So what does it mean? This is P of t given d bar, right? So probability that okay, let me go there. Probability that they show positive in the test given that they are not taking drugs. Probability of test positive given that they are not taking drugs, right? D bar. So that is 1%, 1 by 100. Okay. And the next part is 5% of those taking drugs test negative. So that means they are testing negative, meaning P of T bar given D. P of T bar given D. So they are testing negative given they are taking the drug. So that is 5%. That is 5 by 100. Okay. Now, why do we require this? Uh, so from here you can calculate that P of T bar given D bar is 1 minus 1 by 100, that is 99 by 100. And similarly, P of T given D is 95 by 100. Okay, this is just 1 minus this. So either they are testing positive or they are testing negative, given that they are taking the drug. So yeah, so now this you got P of T given D, that you got 95 by 100, right? And P of D, let's see, yeah, suppose that 2% of those tested are taking drugs. So P of D are is basically 2%. So that is also given. P of D is 2 by 100. So that is also given, right? So P of T given D is this, P of D is this, P of T. So this is a tricky way. So as I said, we'll calculate this using law of total probability. So how do we do it? P of T given D times P of D plus P of T given D bar times P of D bar. Okay. So out of the people who are tested positive, either they are taking the drug or they are not taking the drug. So we'll sum over both, right? And then you just put in the values, right? So then there is nothing left. Okay, so while solving these kind of problems, just remember there are like two things. First, you have to apply Bayes theorem over here, and then in the denominator, apply law of total probability. Okay, just two things you have to remember. Rest all should be given in your question. Let's try to find the what are the given in the questions. You'll see that okay, these parameters are given in the question. Okay, and from p of uh, you know, so if the opposite is given, the t bar given d is given. From there, you can calculate p of t given d, right? Also, one thing you should understand that p of t given d bar and p of t bar given d bar should add up to 1. So that's why the this probability is 1 minus this probability. So yeah, this is a good example of where we need to use both Bayes theorem and law of total probability, and I think you should expect one question like this. So as I said, practice this and see how it's happening. So again, you see that we have P of D bar over here. So again, P of D bar would be basically 98 by 100. So everything will be given in the questions, all those probabilities. And you just have to calculate this. Anything else? Okay, if not, then let's end the session and the course here, and wish you good luck for the final exam. And yeah, it was a nice experience with you guys for these 8 weeks, and I hope you guys do well in your exam, and uh, you know practice all those things, and keep on doing this, and maybe in future you would be doing it as well, doing the this machine learning techniques which you have learned here. You'll be able to apply it in whichever places you are, and in jobs or in internship or in projects or anywhere. So yeah, let's uh, uh, end this session then. Yeah, and yeah, so my YouTube link, let me see. Let me, yeah, we can stay in touch in future via YouTube. So yeah, you can go through my uh, videos, and maybe you can ask questions in the comments if you have, right? So we can stay in touch by YouTube. So this is my link that I have shared here. Okay. And yeah, hopefully we will stay in touch in future, and uh, wish you a good uh, career in machine learning in future. And let me know if you face any problems in understanding any particular concepts, and maybe I will uh, share some additional material on that, or try to share some references on that, or try to explain in detail. Okay, so you have computer-based exam, how to do these type of calculations. Uh, yeah, I don't know if calculators are allowed. I don't know the instructions. Maybe you can take a calculator, and if they don't allow, uh, either you will be provided, a calculator is provided online. Okay, so then it's not a problem, right? So maybe yeah, that will be easier for you. Okay. Yeah, but you should practice these calculations on your own, and yeah, try to solve more and more problems as much as possible. Okay. Yeah. With that, let's end, and I hope we keep in touch in future. And yeah, all the best again. Bye bye. Have a good one. Thank you. Yeah, thank you everyone. Thank you, Satyesh. Yeah. Good night and all the best. Bye.